The Swift 6 language mode is quite tricky. In today's video, we're going to take a look at a compiler error that you will most likely run into multiple times in your project once you start either enabling strict concurrency checking or opt into the Swift language mode entirely. My name is Donnie Walls, and I love working with Swift concurrency. It's got some rough edges, but I really do enjoy working with it. So if you're interested in that, make sure to check out my video course where we dig deep into Swift concurrency, or my book on the same topic. If you're not subscribed to this channel, make sure you change that right now. In this channel, I talk about Swift concurrency, testing, all kinds of Swift related topics that I enjoy working with. So in this video, we're going to take a look at a specific compiler error that reads passing closure as a sending parameter risks causing data races. That error is pretty tough to understand. So let's just jump right into a demo where I'll show you some code and we decipher this error together and we figure out how to fix it. Let's go. Okay, so what we're looking at here in Xcode is a pretty simple bit of code. It's overly simplified, so a lot of things are empty or just fake, but the error is very real. The error that I have, I'll read it for you, is passing closure as a sending parameter risk causing data races between code in the current task and concurrent execution of the closure. This is an error in the Swift 6 language mode. Closure captures self, which is accessible to code in the current task. That's a lot to read. What it's basically telling us is that we are creating a task, right? This task right here. And that task runs concurrently with other tasks. If we call fetch users multiple times from different tasks, and we have parallel calls to fetch users essentially, this task is going to be running in parallel with others. So let's assume that we have at least 2 of these tasks running at the exact same time. Both of these tasks are going to fetch new users from the network. This is probably fine because we don't really interact with any mutable state here. We don't really do anything that could cause problems. Here's where the issue is though. We assign a new set of users to the property users of self. So if I change this to be a little bit more explicit and I write self.users equals new users, you can see that we're actually making a change to self inside of this task. And that's what the compiler has a problem with, right? And again, the error here is really tough to read and is not even presented on the line that's causing us an issue. It's simply telling us that we're capturing self inside of this task, and that could be problematic. We can demonstrate this by making this capture explicit. The error did not go away even though we don't mutate self anymore. So the compiler really does not like the fact that self is even accessible inside of this task, right? Because it's assuming if multiple tasks can access self at the exact same time, there is a possibility for a data race here. So there's a couple of things that we can do to fix this. One approach would be to, and that's probably the better case in most scenarios here, but we'll actually take a look at how it might not work out as good. But the simplest approach might actually be to just mark this function as async throws and do this. Right, no more compiler errors, no more warnings. This is great, everything works. Now the issue here might actually be that if we make a new SwiftUI view, right, I'll go ahead and make that here. We give it a state var of my view model, and besides the fact that this view model is not even observable, right, we're interested in kind of seeing how this blows up. So we'll make a var body, which is going to be some view. We'll have a text hello world, and we'll create a task so that we can actually call my view model's fetch users function. Now we get into an error saying that this call can throw. So we'll do catch this, print, error, and we'll try to await view model fetch users. There we go. Now we're actually having another compiler error that is going to be an error in the Swift 6 language mode. capture of self with non-sendable type myView in a sendable closure. This is an error in the Swift 6 language mode. So we're essentially back to where we started. Right? And that is rather frustrating. If we actually make our struct conform to view, we get a different kind of error. It says sending self view model risks causing data races. So no matter what we do here, we're going to end up in a situation where we might have a data race because in this case, my view model is not sendable. And this is actually giving us a hint of what a better solution might be. So getting rid of the task here, it didn't really solve our issue. So I'm going to go ahead and revert back to that situation because that's really the kind of situation that I'm interested in showing you for this video. But actually the solution is going to fix all three of the problems that we had earlier. So passing closure as sending parameter risks causing data races between code in the current task and concurrent execution of the closure. This is an error in the Swift 6 language mode. Okay. Self, in this case, is causing an issue because self is accessible to code in the current task. And what this is really telling us is that it's not safe to be using self for multiple tasks because like we outlined earlier, if we have two of these tasks running at the exact same time, mutating users is going to give us a problem. So we need to figure out how to get the user's view model to be sendable. Now, I have mutable state here, and that's going to make it hard to make user's view model sendable. Making it sendable would mean that it's safe to interact with the user's view model from multiple tasks at the exact same time. For classes, like our user's view model, this means that the class cannot have any mutable state. Because as soon as a class has mutable state, it's no longer safe to interact with from multiple tasks. One approach might actually be to mark this as an actor. Right? If we run this code now, we get a different error, but we also have somewhat of an issue here because we forgot to make our user's view model observable. And then we get into an issue where the compiler is going to tell us that an actor cannot be observable. But if we are actually using this view model in a SwiftUI view, we do want it to be observable. So that's not going to work. I need to keep this as a class. So what else can we do then? Well, we could mark this as sendable ourselves. We can make this a final class, and this actually works. I told you that we couldn't make this sendable because we had that mutable state, but suddenly this worked. And that's because of the observable macro, right? I'm not going to go into that too deeply. The observable macro kind of changes our code so that the code that actually runs and gets compiled is not the code that we're looking at here. I personally do not like this solution. So what I typically tend to do is to make all my view models MainActor annotated. What that does is it makes it so that everything that I do in this user view model is going to be isolated to the MainActor. So if I have multiple calls to fetch users happening at the exact same time, and all of these calls make new tasks, then interacting with users is actually going to be done on the MainActor. Right? This function fetch users exists on the MainActor. This task inherits the MainActor, so it also runs on the MainActor. And then this assignment right here to users is going to be on the MainActor. And this makes sure that everything is streamlined. And this implicitly makes user view model sendable. It makes it safe to work with my user view model for multiple tasks at the exact same time. Now let's take another look at that sending self-network risk causing data races, because it's a similar kind of problem. Networking is not safe to use in multiple tasks at the exact same time because it's not sendable. Now, if we actually look at the implementation here, networking does not have any state. So without digging too deeply into what we can do with sendability, because that is quite the big topic, I can just go ahead and make my network sendable, right? Because it's got no state. I can make it a final class, mark it as sendable, and be done with it. If I would happen to have some state on my network, since it's such a deeply asynchronous kind of object, maybe it would have made sense to turn it into an actor. Doing that same effect, it also works. I think making it an actor in this case is a bit too much. I don't have any mutable state to protect, so I want this to just be sendable. That way I get the behavior that I like to think I want to have. So that was quite the adventure in just a very short video, right? We took that error that said that we were not using the sending closure correctly because we were capturing self and that was not allowed. We deciphered that into meaning if you're passing self, which is not sendable, into a task, then the compiler is going to assume that you might be doing that multiple times concurrently. So it's going to assume that you might have multiple tasks running at the same time and that all of these tasks might be interacting with self. Since self is not protected from data races because it's not sendable, the compiler is going to stop you right there and tell you that you need to fix this before it becomes a problem. The fix in this case was to make sure that our view model was sendable. I showed you how you can do that by using the observable macro combined with the sendable protocol. That just happens to work. I do not like that as a solution. Then I showed you that you could mark your view model as MainActor annotated. Now, I only showed you that because I think the view model is something that should probably run most of its work on the MainActor. You're not really interacting with the view model from anything other than the MainActor. You're always going back to the MainActor. So kind of staying on the MainActor inside of a view model just makes sense to me. If that doesn't make sense to you, then well, you could use that observable, sendable kind of hack, I would almost call it. But yeah, I don't like that. So this, to me, is really the best way to get our user view model to be sendable and to actually get rid of that compiler error. I hope this video taught you something. I hope this helped you understand how you can think about these kinds of compiler errors where the compiler is telling you this is not sendable or this cannot be sent to another task or those kinds of wordings. And I hope that you now have somewhat of a recipe that you can apply to a couple places in your code base. If you want to see more of this, make sure to subscribe to the channel, hit the like button, notification bell, and all of that. And then I will see you again in the next video. Thanks for watching.